In this video, we're going to see how to do a chi-square test on a set of data that have been taken from an experiment where we count up the number of patients who fall into different categories. So here we have, we've given 100 patients, we've divided them into two groups. 50 of them have received ondansetron and 50 have been given dexamethasone. And we counted up in each group how many had nausea postoperatively and how many did not have nausea. Okay, so these are the numbers we have. So we can see from this that 38 out of 100 in total had some kind of nausea, whereas in the ondansetron group it was 16 out of 50. Now the question we ask is this difference significant? So the first thing we need to do is construct a table of the expected values. What will we expect it to be if the null hypothesis were true? Okay, well the way we do that is we make it here. And in this cell, we're going to put in, for each cell, we have the row total multiplied by the column total and divide that by the grand total. Okay, so the totals for the rows are here, the totals for the columns are here. So for this cell here, it corresponds to the 16 of the ondansetron patients who had nausea postoperatively. So the row total is 38. Okay, so I write equals cell T4. Okay, now I want to keep it in row in column D for these, so I press F4 to make it say $D4. Okay, and now I multiply that by the column total, which is in this cell here. Okay, I want to stick with row 6, so I press F4 and that makes B6 with $6, and then I divide that by the total sum, which is in this cell here, D6, and I make it $D6. Okay, the point of the dollar sign is when I copy this formula across and down, the one that has the dollar will stay constant. Press enter, and I get 19 is what I would expect if the null hypothesis were true. Now all I do is drag this across. I copy it across one, I copy it down one as well, and these are the expected values. Now what we observe is, if I then type in the formula here to get the sum should stay the same. Okay, so the sum should stay the same. We do the same here. Sum of those is that. Sum of those is that. And the total sum is here. So the row sums and the column sums should remain the same. I'm just going to highlight these in a little box so that it makes it clear as to which ones are the actual numbers and which are the totals. So now, these four cells here, these represent what I would expect if the null hypothesis were true. Okay, well, I get from that, they are a little bit different from what I observed. So for example, there were 3 more in this cell than I would expect there to be, and there's 3 fewer in this cell than I would expect there to be. Okay, so is this significant or isn't it? Well, what I do is I calculate the chi-squared statistic, where I work out the observed minus the expected value divided by the expected. Okay, so this one here is going to be the observed value, which is that one. I'm actually going to put that in a bracket. So the observed value minus the expected value, which is that one. Close the bracket, square it, so to the power of 2, and then I divide it by the expected value, which is that one. Press enter, and that's my squared residual. Okay, and then I copy this formula across one, and then down one. So I've worked out the squared residuals here. Okay, the chi-squared value is simply the sum of all these 4. So it equals sum of all those. Okay, so that's my chi-squared value, 1.52. Well, is that significant or isn't it? Well, we could look this up in a table of chi-squared values, but fortunately we have Excel to do it for us, so it'll do that calculation for us. I just said equals chi-squared, okay, and it's the chi-squared dot distribution dot right. I want the right-tailed probability, okay. So the value I evaluated at is x, which is this chi-squared value here. The degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So that's 1. 1 degree of freedom, and there's the probability value. My p-value is 0.21. So with a p-value of 0.21, I can say that these data are perfectly consistent with the null hypothesis. If I can't remember this formula, okay, well, Excel will do it for me. All I need to do is type in this formula, which is chi-squared test. There it is, chi-squared test. And if I have the actual range, which is these are what we actually found, comma, and then the expected range, okay, Excel will then work out for itself what the degrees of freedom are, and it will calculate the p-value as 0.216. So there's a slightly shorter way of working out that calculation. So this is how I use the chi-squared test for a 2x2 contingency table.